All right, hi, welcome. In this video, I'm going to go over some features of C and C++. So let's get started. The first thing I'm going to do is I'm going to type in W3 Schools and show you this website. So W3 Schools online web tutorials. So I highly recommend going here to the C++ tutorials and going through and learning about C++. It just goes very, this is a very good website, whether you want to learn C, C++, Python, some other languages. This is a very good website and it is listed on Canvas. So if you don't remember, but it's W3 Schools. The next thing I want to do is I want to go to an online C++ compiler. Now, you can use any compiler you want for this course. As a matter of fact, when you submit your assignments, they're just going to be plain text like this. This is just plain text program. And I will post this for you so you can practice before, after watching this or along with this video or whatever. And I definitely recommend practicing and getting comfortable with whatever online or if you download a compiler that you're going to be using for this course or IDE. So I'm going to use this online compiler and you can use whichever one you want. I'm just going to choose to use this one if it loads up here. And then this is code. This is in a um, notepad. This is just a plain notepad source code. And you can just say file, save as. And when you save it, like intro code, or I could call this pies.cpp, you just add a .cpp extension. It's still a plain text document. It's just a CPP extension to indicate that it's C++ source code. If you are using an Apple computer, I highly recommend that you go into your text edit and change your text edit to the feature of plain text because by default it's rich text. And if you take text like this and try to put it into a compiler and it's not plain text, it might add things and you'll have problems. So first, I just open this up. All I did was type in online compiler, go here, and it already gives me a setup with comments at the top and it's ready to go. So if I run it, it should print hello world onto the screen. And this is my feedback window. It's printing hello world onto the screen. Now I'm going to take my Pi code and I'm going to put it in here. So you will notice right here that in order to use cout is part of the standard namespace. If you don't want to use this scope resolution operator with STD every time you have a cout, you can put using namespace standard at the top of your code. And when you do that, you don't have to do this every time you have cout and cin. In this case, I would have to have this for cout. I would have to have this for cin. And I don't want to do that. So what I decided to do is put globally on top of my code using namespace standard. Now this program has a extra feature because I decided to include the string class. So I've declared a string called name. I've asked the user to enter their name and then I get their name. And then when I'm doing some output to the user, I'm including the name in that output. Couple more things about this code. At the top of your code, you should have a header that has your name, date, a brief description of what this program does. This calculates the total slices of pie based on the number of pies and the number of slices per pie. That is what a description is, not this is assignment 2. That doesn't describe what the program does. There are two ways to comment. You can put a whole bunch of comments or just a few in between a forward slash and asterisk, and it ends with an asterisk forward slash. Or for one line comments, you can just put two forward slashes. So all programming languages have different ways to comment. Comments are ignored. They are notes to you. And since you're taking a class, they are notes to whoever's grading your assignment. It's very good to get in the habit of adding comments throughout your code. So here we go through here. We have our main function. The main function doesn't take any arguments. You can put the word void there, or you can leave it out. Either way is fine. But at this point, we're not doing any programs in which we need to pass anything to the main function. So leave this blank or put the word void there. The main function has an integer return type and we're returning 0. That means our code executed as expected. So be sure to include the return 0 in your code. In addition, we have a block. We have an opening curly brace and a closing curly brace. And although indentation doesn't matter, it matters in the class because it makes the code much easier to read. This is an interactive program that's going to read in from the keyboard, do a small calculation, and print results onto the screen. So let's test it and make sure it works as expected. So this is working as expected. There isn't any issues. If I were to maybe leave off a semicolon here, it should not compile and it'll give me some feedback here in the window letting me know why it didn't compile. Sometimes it's very obvious. I forgot my semicolon here. And sometimes you're going to get feedback that you're just not quite sure why it didn't work, but you will, through trial and error and practice, figure it out. That's the point of taking a class and trying to learn and figure out, what the problems are and solve them. All right, so that's just an overview of using an online compiler. We could find a different online compiler. We could try a different one, like there's this one. I can put my code in here. And I've never used this one. I just thought I'd give it a try just to see what happens. And I'm assuming I'm going to have to run it here. So, oh. Click the run button on that. Oh, it's below my thing here. There it is. All right, so it's compiling and this one is a lot slower, but uh, anyway, I'm not a fan of this one, so let's try another one. So I use this GDB one. It just has ads and sometimes it does weird things. A lot of students have used this one right here. We can give this one a try. My recommendation is that you use whatever one is going to make you comfortable. So this one seems to work pretty good. And you just pick one and you're going to be using it for the entire semester. So you can download, there's a whole bunch of tools out there. Um, just to find one that makes you comfortable. But in the end, you're just going to be submitting plain source code. You save this file, save as anywhere on your computer. I can save this as pies.cpp, which I think I already did, but that's okay. And then if I go here to where I saved it on my, here, here you will see this is my source code file. So it's just a plain text file. If I open it with Notepad, that's what I would submit for my assignments. So just practice and figure out what you're going to be using for your compiler. I put a couple of recommendations, but I want you to be comfortable with what you're using. All right, so now let's go through some slides here. So transitioning from Python to C++, this is more of an overview of C++ and C, and some of you have already used Python. So again, some of the features we're going to go over in this presentation, we will go in much more detail throughout the semester. This is just an overview and introduction. So let's go over some terms, compiled versus interpreted code. C and C++ are compiled code. That means that the program is translated into machine code and before it's run on a computer. That means if you take a C++ program and you compile it on a Windows machine, it will create an application that works on Windows. You will have to take that same source code and recompile it on a Mac computer because you can't the application that is created, although the source code can be portable to another, another any tool because it's plain text, the application is tied into the machine in which it was compiled on. Interpreted is more portable and can be used, is not translated into machine code, is not as tied into the operating system, and an example of that is Python. So this term multi-paradigm, C++ is a multi-paradigm language because you can structure the code in different ways. It's not set in just being object-oriented. You can do procedural programming in C++. C++ is an extension of C, and therefore you can use the C++ code in different ways. So let's take a look at this table here. This is features of C, C++ compared to Python. So again, Python is interpreted where C and C++ are both compiled. Python has dynamic data types. C and C++ have static data types, meaning they know what data type it is. When it's compiled, you have to declare it, give it a type, and it doesn't get automatic dynamic typed and it doesn't get automatically assigned. You give the data type like int num and assign it a value, or like char letter and assign it a value. So that's a static. That means that the data is given and known before compile time. Python has automatic memory management. C has manual, and C++ have manual. Dynamic memory management. In C, you use malloc to dynamically allocate memory. In C++, you use the keyword new. And then to free up memory, you use free in C and delete in C++. Python is slower but more portable, and C and C++ are faster. Python is an object-oriented high-level language. C is a low-level procedural language, which means that you give every statement and instruction that you want, statement by statement. C++ can be procedural, and it also adds extra features and object-oriented features. So let's look at a difference between compiling and running the different programs. In Python, you just type in print and you put whatever you want to print onto the screen inside of parentheses, and you don't need a semicolon or anything, and you don't need a main function. In C, you need to have a main function. In order to print onto the screen, you use a function printf. Printf is in this library right here. All statements end with a semicolon, and very, very importantly, you need to have a main function that tells where to start execution. C++ is the same. C++, the difference in printing onto the screen is you use cout. You still have the main function, but you use iostream. But keep in mind that C++ is an extension of C, so therefore, if you really wanted to use printf in C, you could include stdio.h in your C++ programs. So after you have done this, you need to have a compiler and a linker in order to turn your source code in C or C++ into an interactive application. Well, this in this case isn't interactive, it's just printed onto the screen, into a working application. All right, syntax in C and C++, you have variables and data types. You have int, double, char, bool, and also there's float. There's more than this, but these are the ones we will focus on this semester. My recommendation is to use double over float. It's twice the size. You're not going to exhaust your resources. Ints are whole numbers, doubles are floating point numbers, characters are single characters, and bools are true, false. We have for control of flow, you have if, else, and switch. We will learn about these in a couple of modules. Loops, you have for loops, while loops, and do while loops, which we will learn more about their syntax and how to use them. Functions. All right, functions have a return type, a function name, and a parameter list. So this would be the return type, this the name of the function. Parameters are what you need to pass to the function in order for it to work. So if you have a function that's going to add two numbers together and return their result, you need to pass it two numbers, two values that are going to be added together. If you have a function that's going to print something onto the screen, you need to pass it what you want printed onto the screen, etc. We're going to learn about the different types of parameters. There are value parameters and there are reference parameters. A function is just a sub-program, so you already have the main function, but the idea is to break up your program into small sub-programs or small units of work called functions. You also can have a return type of void. A void function does not return anything, and when calling the function, it is just an executable statement. We also have pointers. The symbol for a pointer in C and C and C++ is an asterisk, and we are going to learn more about pointers in C and C++ because they are very powerful for allocating and accessing data. So let's talk about data types in C and C++ versus Python. So in C++, you must end a semicolon for every time you declare. Also, even if you don't assign a value, so this is declaration and initialization. The data type is an integer, the name of the variable is age, and it's getting assigned the value 25. This is a double pi, assign the value 3.14. You can also say int number, and this will allocate memory, but it will not assign any value to it, so you cannot assume that a values get assigned in C++. In Python, you don't need to put the data type and you don't need to use semicolons. All right, flow of control in C++. So example of a condition. So this is a condition, it's a block of code. You use the word if. So we're saying if age is greater than 18, this is a Boolean expression. So you have a variable called age and it has a value. So if you have age and the value is 20, then this is going to evaluate to true and it's going to go inside of this curly brace and print that onto the screen. Else takes care of everything else. So even if age is negative 50, that would be part of else. Now, if you didn't want to accommodate negative numbers, you would have to do something about that. But this code right here is only any age that's greater than 18 is going to go for the if condition, and any age that is less than or equal to 18. Okay, so greater than 18, this is probably not true because 18 is not a minor, but greater than or equal to is not the same thing as greater than. You can also have an if without an else, like you can say if num is equal to 10, for example. I'm not required to have an else. So a lot of times students think every time you have an if, you have to have an else. You don't. And in C and C++, equals equals is how you compare. If you do a condition like this that says num equals 10, that is assignment, and that is always going to evaluate to true. Where this must be a 10 in order for that to evaluate to true. Here's an example of a loop. This is one type of loop. This is a for loop. In C and C++, there are three types of loops. There are for loops, there are while loops, and there are do while loops. For each loop, you want to deal with a few things. So the first is realize that there's initialization, there's a test, and there's an update step. So in this case, when you're using a for loop, the initialization, the test, and the update are all in the header of the for loop separated by semicolons. In a while loop, if I wanted to do the same thing with a while loop, I would have int I equals 0, while I is less than 5, and then you're going to do something. So C out, I is I, and then I plus plus. So this I plus plus, that's the same thing as saying I equals I plus 1. Same thing, doesn't matter. I plus plus, I equals I plus 1. You just take whatever value is, add 1 to it, and assign it back to I. Yeah, so this loop will run 5 times when I is 0, 1, 2, 3, and 4. Once I becomes 5, the test is 5 less than 5, and that becomes false. Functions. So C++ has functions. How you define a function is also a block of code. We are going to go over placement of functions. This is just overview. The return type for this function is an integer, which it's going to take in a value here and a value here, and it's going to add them together and return that result. So whatever this is, return is a keyword. This must be an integer as well, which it would be if you take two integers and add them together, their result should be an integer. This is the name of the function, and this is the formal parameter list. In order to use this function, I must pass it two integer values. So here is how I would call that function. This is the name of the function add. And again, this would have to be inside of the main function or inside of another function. But this code doesn't just reside, just sitting there in your program. Everything is nested inside of some type of block of code, which you will get used to as we start working on your programs. So you will see here that this will come in, and when this function gets called, it'll be like int a equals 5 and int b equals 10 because we're passing the value 5 here and we're passing the value 10 here. So this is fundamental function stuff. This is what's called an integer function because the return type is an integer. So when this function returns, I need to have a place for that integer to go. There's void functions, integer functions, double functions, character functions, string functions, and then when we learn about our own data types, you can make functions for those as well. All right, a little bit more about C++, C programming and C++ programming. So C uses pointers and memory addresses, which we will get into this semester, also in C++. But let's just go over again, just to review the structure of a C program. The C program uses stdio.h. This is a preprocessor directive. In C++, you use IOStream. This is defining the word pi. Everywhere in your program where you have the word pi, it will be replaced with 3.14. So for example, if I wanted to say double x equals pi times pi, everywhere there's this word pi in my code, it will be replaced with this number 3.14. This is a constant. Why is it a constant? I'm not changing what pi is in my program. I'm just replacing and using the word pi for a number. Motivation for doing this? Well, what if I was doing a big circle program and I had pi in my program 50 times? And then I decided, I want to be a little more precise in my circles, so I want to use 3.1415. Well, this way, I don't have to go through everywhere in my code where I had a 3.14. I just have this word pi. So now everywhere where it used to be 3.14, it will now be replaced with 3.1415. We went over already. All C and C++ programs have a main function. We have variables and data types. We are going to go over the placement of function prototypes and function definitions in probably module 3. We're going to get right on to functions and return values. So a little bit more about the data types in C and C++. We have integers, floats, characters, doubles, and functions with no return value are void functions. So this is just about the size. It's not really a big deal, but my recommendation is to use doubles only because of the fact that a double will be able to accommodate more precision and will be able to do larger math with it. But you can use float as well. Keep in mind, like the number 3, that's an integer. As a float, it's 3.0. As a character, it's a 3 in single quotations, and a 3 in single quotations does not have the ASCII value of 3. And a double would be 3.0, but it would take up more space in memory. So we already went over flow, but let's just go over it again. This is X has a value. So if this is true, it's going to go in this curly brace. And if it's not true, it's going to go in this curly brace. So in this case, X is 10. So it would go here. But if I said here X equals 2, that's going to override it because everything in C and C++ starts at the top and only knows what's above it. So this is declaring it has a value 10. This is changing its value to 2. This is testing if it's greater than 5. It's not. So then it's going to go into here. We already went over loops. A little bit about pointers. A pointer is a variable. So pointers, if this is a memory map, you do have pointer variables. So if I declared here int num equals 25, this is not a pointer. This is a variable of type integer called num. My operating system is going to find a space for it here. It's going to have the value 25, and it's going to be located at this location. So num will have an address of num. Then if I declare a pointer, so an integer pointer can only point to an integer. A double pointer can only point to a double. But when I declare this integer pointer, what do I get? I get PTR, which is a pointer that points nowhere. So pointers can be very tricky because they have to, you don't get memory allocated when you declare a pointer unless you point it somewhere. So what I can do is I can say pointer equals address of num. And then what happens, it will take this PTR and point it to this location. We're going to do some practice with this later in the semester. All right, so there are 2 symbols used with pointers in C and C++. The asterisk is used to declare a pointer. The asterisk is also used to dereference a pointer. So right here, if I want to say where is pointer and I want to find out what this value is, I say value at PTR. So we have this symbol can be value at, and this symbol is for address of, and this symbol is also used to declare a pointer. So we will be learning more about this semester. So that's exactly what I just did. All right, so you have to be very careful when you are handling pointers because you don't want to point to nothing. The data type of the pointer must match the data type of what it's pointing to. A little bit about C++, and you're going to see that almost everything we're going to talk about here in C++ at this point in the introduction here, other than how you input and output from the keyboard, is the same as C. So the only thing we're going to add is I'm going to show you what it looks like to declare a class. So here is the C++ program. Just like a C program, you have your preprocessor directives. So instead of using io.h, you use iostream. To avoid having to put the std in the scope resolution operator, you can say use namespace standard, then you don't have to add that. You have the main function. The only difference is that instead of using printf and scanf, you use cout and cin. You can also define macros and define constants at the top of your program. This was C. This is C++. C++ has the same data types. The only thing is that you now can add the data type bool that is not part of the C language, that is part of the C++ language. The flow is the same. The only difference here is how we're printing it onto the screen, but conditions are still the same. There's still blocks of code. You still use Boolean expressions, and loops are also the same. The only difference here between C and C++ when it comes to loops is, of course, if you want to do input and output, you use cout and cin instead of printf and scanf. Now here's a big feature that is added to C++, and that is the classes. You can create classes and you can put functions and data all part of your classes. And we're going to be spending a lot of time creating and doing code that includes classes. So classes are, you use the keyword class. The data and the methods in your class can be either public, which means they're available outside of your class, private, which means that they're not only available to members of your class or friends, or protected. But we probably won't use that, so we're going to stick with private and public this semester. Now, once you have defined your new object, it's called car, your new class, you can declare objects of type car. So you have, this is an object of type car. This is the name of my object. So, and you use what's called the dot operator to access the member functions and the member variables. As long as those member variables are public, you can just access through the dot operator, which we're doing right here because they're public, but we are going to learn about how to use private member variables and accessor and mutator functions. Don't worry, we're going to be doing that. All right, so that's just a little overview about some of the features of the C and C++ languages. And in the next module, we will start working in detail on C++ basics.